Okay, expand. Okay, keep your expansions ready in your notebook. You need not have to show them. Okay, these are easy ones. Then the next, AD plus AE plus AF plus BD plus BE plus BF plus CD plus CE plus CF, AC plus AD plus BC plus BD into E plus F. That makes it AC, or let me start from here. AC E plus ADE plus ADF plus, array, mistake, came in between the mid. Okay, ACE, ACF plus ADE plus ADF plus BCE, BCF plus BDE plus BDF. Okay, so if if we observe, there are two terms in the first bracket and two terms in the second bracket. And in RHS, if we observe, there are total 4 terms. Every term consists of one term from first bracket and one term from second bracket. These are our observations. We are just doing our observations. In the second example, it is not happening that we end up having term AB, both the terms from the same bracket, not available. That these are the observations. In third, first bracket has 3, second bracket has 2. After expansion, we have 6 terms. Every term in RHS has one letter from first bracket, another letter from second bracket. Again, there is no term in RHS which has both the letters from the same bracket. Observation of 4. There are 3 terms in first bracket, 3 terms in second bracket. And hence in RHS we have total 9 terms. Again, every term has one letter from first bracket, letter from second bracket. Very good observation. In the fifth problem, we have 3 brackets of 2 terms each. In total, we have 1, 2, 3, 4, 5, 6, 7, 8 terms in RHS. Number of brackets were 3. Therefore, every term had 3 letters. one from each bracket. That is what is our observation. Now, as far as the first problem is concerned, we can write it as a plus b into a plus b. That makes it 2 in the first bracket, 2 terms in the second bracket. Therefore, by the logic of 2 to 5, we should have 4 terms in RHS. They are going to be a into a square plus ab plus ba plus b square. So there are 4 terms total. In total, if we calculate each and every term, there are total 4 terms. However, because multiplication is commutative, AB and BA look alike. Therefore, we can write this expansion as a square plus 2 times AB plus B square. So eventually we end up having 3 distinct looking terms. And here from 2 to 5, every time the coefficient of each term was 1. However, this is the first time we end up getting the coefficient of this combined term as 2. Because we don't want to write it like this. This is ugly. This is long. Therefore, we club them because we know multiplication is commutative and end up getting 2ab. Let us expand. 6. Suppose I had a plus b, a plus b, and one more times a plus b. Then what would happen? 2 into 2 into 2. So there we expect total 8 terms here, 2 raised to 3. That is what had happened here. 2 into 2 into 2, total 8 terms. Here 3 into 3, total 9 terms. That is what our observation. 3 into 2, 6 terms in this case. 2 into 2, 4 terms in this case. So we expect a plus b into a plus b into a plus b is equal to, we should end up having total 8 terms. However, all the 3 brackets look alike. Therefore, because multiplication is commutative, we may end up having distinct looking less number of terms. So, distinct looking first term could be a cube. Distinct looking second term could be a square b. Now, when I am writing a square b, I am selecting 2 brackets out of 3 from where I choose a and the remaining bracket I choose b. Then there could be one more term ab square. This is another distinct looking term, and maybe we have one more term distinct looking, which is b cube. We cannot imagine of any other term which is distinct looking. Now, a cube can be generated by choosing a from each bracket. Choose a from first, choose a from second, choose a from third. That is how you can choose 3 A's from 3 brackets. Practically it is either 3 choose 3, or if we talk about B, then it is 3 choose 0. So you are aware, I don't spend much time on this. Here I can choose 2 A's from 2 brackets and 1 B from 1. Therefore, this is going to be 3 choose 1 or 3 choose 2, which is a small number. Therefore, it is 3. It is 3 choose 2 or 3 choose 1, depends on what you are talking about. Again, 3, 1. I am sure all of you are aware of this. And hence, maybe 7 a plus b bracket raised to 4, I would like to write, instead of doing it in this way, if I choose 0 b's from all the 4 brackets, okay, and my each term will have 4 terms total, 4 letters. Therefore, from 4 brackets, I should choose 0 b's with respect to b. If I talk 0 b's, then I will end up having all a's. Then from 4 brackets, if I choose 1b, in how many ways we can do it? 4 choose 1 ways. Then I will end up having 1b and 3 a's. Then from 4 brackets, if I choose 2 b's, then I will have term a square b square. Then from the 4 brackets, if I choose 3 b's, then I have term ab cube. And then from the 4 brackets, if I choose 4 b's, then I have term b raised to 4. That is how my expansion is going to look like. But if I want to see it in our normal way, not choose notation, no complications, then orally we can do these calculations for choose, and it will look like a raised to 4 plus 4a cube b plus 6a square b square plus 4ab cube plus 1b raised to 4. And hence, the coefficients which are sitting in front of all the terms in the expansion are called combinatorial coefficients or binomial coefficients. Binomial because we are talking about 2. Binomial.
Sir,
एक मिनट. Binomial because we are talking about 2 terms a and b in each bracket. And hence these are called binomial coefficients. These are called binomial coefficients because we are essentially discussing the powers of a plus b. Okay, and hence now the task given to you, which is very easy, is write down expansion in choose notation, maybe a plus b raised to 7.
sir, sir, actually I was disconnected in the sixth and seventh question. Can you re-explain how did you get that choose notation?
Will look like 7 choose 0 a raised to 7. 7 choose 1 a raised to 6 b plus dot 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 plus 7 choose 6 a b raised to 6 plus 7 choose 7 b raised to 7. It is very simple. Having understood what the choose notation is, writing this coefficient is absolutely easy, and hence now we are going to write down celebrated theorem a plus b raised to n, where n is a natural number, is equal to, add all those terms, start from 0. Oh, I don't know whether you know this notation or not. We will discuss about it, or maybe not now. Is equal to n choose 0 a raised to n plus n choose 1 a raised to n minus 1b plus n choose 2 a raised to n minus 2b square plus dot 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 plus n choose n minus 1 a b raised to n minus 1 plus n choose n b raised to n. Now, if you want, you can write b raised to 0 here and a raised to 0, a raised to 0 b raised to n. In the end, that will ensure, that will help you to remember this number and this number is same. This number and power here is same. This number and this number is same. This number and this number is same. This number and this number is same. That is what is celebrated binomial theorem. By the great Isaac Newton. Okay. I don't know whether I had made this recording on. So this is the expansion of a plus b raised to n when n is natural number. As simple as whatever we have done for power 7, we should do for power n. N choose 0, a raised to n, b raised to 0, n choose 1, a raised to n minus 1, b. So on, n choose n, a raised to 0, b raised to n. This is called binomial theorem, and the one who did it for the first time was Isaac Newton. Now, let me discuss summation notation. Because students of mathematics are lazy and they don't want to keep writing like this long additions. Immediately we would like to find out a notation by which we can exercise our laziness very quickly. And therefore, suppose question 1, I want to add 100 natural numbers, 1 plus 2 plus 3 plus 4 plus, I mean, I have created a notation dot dot dot, which means all of them in between are available, but still it is very long and I don't want to spend my energy in doing this. Therefore, I say add, that is sigma means add all the natural numbers. N goes from 1 to 100. This is called summation index. N is called in this case summation index. Maybe let me write down. What is this? This is summation index. What is this? Sigma means add. It is capital Greek alphabet sigma. Add or sum. From starting point n is equal to 1, where should you stop? 100. And what you should add eventually? You add n. So this will be read like this: sigma n goes from 1 to 100 n. That means when n is equal to 1, 1, when n is equal to 2, 2, n is equal to 3, 3, something like that. Okay, that is what is the notation. Up to, this is summation of 100 natural numbers. Yes. Recording also. Okay, so if I solve first problem, I know how in sigma notation how it looks like. So I just want to have one more property of sigma. Can I break it up in two parts? How many terms are there in this? 45. How many terms are there in this? 55. Practically I can break it up in whatever number of steps that I want, because sigma is addition and anyway I am doing addition. Therefore it is overall addition. So you can break and create whatever number of sigmas that you want, no problem. Cheap. Next property. Suppose now question 4, I have to add 2 plus 4 plus 6 plus dot 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 plus 44. Now write down your sigma notation and show it to me. For this addition, you start with n is equal to 1, but you want 2. Therefore, 2n. If n is equal to 2, 4. N is equal to 3, 6. N is equal to 4, 8. And up to what you should go?
22.
22 is 44.
44.
Okay, good. But then this summation is exactly equal to 2 inside bracket 1 plus 2 plus 3 plus dot 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 plus 22. And therefore I can write it as 2 inside outside sigma n goes from 1 to 22. Is this exactly equal to sigma n goes from 1 to 22 2n? So do we get a property here? Do we get a property here of sigma notation?
Yes, sir.
Yes, sir.
The property of sigma notation is sigma n is equal to 1 to n is equal to k, or upper limit is k. K is our coefficient. N is equal to n. N goes from 1 to n, or maybe sometimes your index is I for index. I goes from 1 to n. And what I was saying, kn. K is where k belongs to real number. K is a real number. It could be 5.7, no problem. Is equal to k times sigma I goes from 1 to n. If there is a constant inside, you can take that constant outside. That is the second property of sigma notation we are trying to learn. Any question? No question. Very good. Question 5. Question 5 is sigma I goes from, I wanted to say something, 1 to 10, 5 is equal. Let me check whether you have understood. Show me the answer. Sigma I goes from 1 to 10, 5. Assume according. I is equal to 1. First term 5. Second term 5. Third term 5. 10th term 5. So summation is 50. Okay. Okay, good. Now the last property of summation notation.
Excuse me.
Yes, yes. Question. Next property. Let us discuss next property. Sigma n is equal to 1. Now, are you fine with n here, or shall I put I? I mean any letter. K is equal to 10. K 1 to 10. Then you should have this fellow over here. In this problem, I am taking this n over here. Okay. So what is the first term? First term is put n is equal to 1 in this bracket and find out the first term. First term is going to be 2 raised to 2, which is 4. What is second? Put n is equal to 2. Makes it 3. 3 square, which is 9. Plus 4 square, which is 16. Plus dot dot dot. Plus 10 square. Let me write for 9 square, which is 81, plus 10 square, which is 100. Do you all understand what I have written?
Sir, I think we have
N
to move it till 11 square.
yes,
We will have to take 10
plus
plus 1 square.
11 square. I am about to write 121. Okay. Have you now understood how many terms are there in RHS? Can you tell me how many terms are there in RHS?
10.
10.
10 terms, correct. And that you need not count and say it is available here. If it starts from 1, then number of terms available here are this. Now I have a question. Okay. This is exactly equal to sigma I goes from 2 to 11. This is exactly equal to sigma I goes from 2 to 11 right here.
I square.
I square.
Are you supposed to spell out? The answer is I square, because when I is equal to 2, 2 square, that is our first term. When I is equal to 3, second term, and last term 11 square. Correct? चांगलं चाललंय. Therefore, now I want to ask you in different color. This sum is exactly equal to sigma k goes from 0 to 9. What? Resume recording. K plus 2. Now let me put little difficult.
Sir, whole square.
Whole square. Yes, correct. You are right. Whole square. Now, so I am not now going to write these people over here. We just play with sigma. Sigma I goes from 1 to 5 to I plus 1.
The new question.
New question new is equal to sigma I goes from 0. Now fill in the blanks. What will you write? Let me change the color for fill in the blanks. Color this. Fill in the blanks. Fill in the blanks. Position A, position B. Report answer. What will you write at A and what will you write at B? 2i plus 1. Sigma I goes from 1 to 5, 2i plus 1. I, if it is 1, then it is 2. So safer side, what I will do if I don't understand the mechanism, maybe I only 5 terms. Let us write down 5 terms. I is equal to 1, first term is 3. Plus I is equal to 2, second term is 5. Third term is, fourth term is 9. Fifth term is 11. This is what I am trying to do. Maybe every time if this is 100, we will not write all the 100, but at least couple of them we can cross check. So there are total 5. If I starts from 0, 0, 1, 2, 3 and 4. I want total 5 numbers to be added. So A is going to be 4. Good. Now if I put 0, I should get first number 3. If I put 1, I should get second number 5. So what we should do here is I is taken back by 1. Therefore, we should put 2i plus 1. If I is reduced by 1, we should make I 1 more. And this is going to be equal to 2i plus 3. That is what we call push-pull. We have pulled back, pulled by 1. If the index is pulled by 1, your summation, what you want to add, should be pushed by 1. In the earlier problem, index was pushed by 1, 1 became 2, pushed by 1. Therefore, the bracket, whatever bracket is there, you pulled by 1. N plus 1 became n. I became I. I plus 1 became I. Here, from here to here, index is pulled by 1. Therefore, summation is pushed by 1. N plus 1 becomes k plus 2. Do you understand? However, whatever you are trying to push here is multiplied by 2. Therefore, it is not 2i plus 2 or 2i plus 1. It continues to become 2i plus 3. And then whenever you do this, and if you are in confusion, what you should do? You put 2i plus 3. Then put I is equal to 0. Are you getting 3? Correct. I is equal to 1. Are you getting 5? Correct. To 2. Are you getting 7? Correct. Therefore, this is correct. Yes, I is equal to 0, and if you don't get 3, then it is wrong. If you put I is equal to 1 and you don't get 5, it is wrong. Yes. Right. I have completed my explanation. Now you can ask. Resume recording. Sigma I goes from 2 to 5. I square plus 3i plus 1. Oh yeah, full and final is equal to sigma I goes from 1 to heart a simplified form b. You don't ask me to do calculations, you do your calculations and show me b. So report answer like a is equal to going to be equal to 4. Barabar? So report b is equal to. Chalo, let us. What is b? I plus 1 push by 1 bracket square plus 3 I plus 1 plus 1 is equal to I square plus 2i plus 3i 5i plus 1 plus 3 plus 1 5. We should put I square plus 5i plus 5. And now if you have a doubt whether our answer is correct or not, what we should do is put I is equal to 2. 2 square, that is 4. 3 into 2, that is 6 plus 1. The first term of this summation is 11 plus second term. No, let us cross check first term. If I is equal to 1, 1 plus 5 plus 5. It seems it is 11. You can at least cross check 1 or maybe cross check 2, because sometimes it might happen that your first answer is correct but second term is not. So if I is equal to 2, I is equal to 3, that is our second term. 9 plus 9 plus 1, 18, 19. This is going to be 19. If second term here is I is equal to 2, 4 plus 10, amazingly it will work, and therefore the answer is correct. Now, by property 1 that we have studied, we can also write this as sigma I goes from 1 to 4 I square plus 5 times sigma I goes from 1 to 4 I plus sigma I goes from 1 to 4, 5. This is easy to calculate. The last rectangle is easy to actually find out the final numerical answer. Question will be this. Interim steps could be this. Finally this. And then once we learn how to find out summation of n natural numbers, this is n natural number, 4 natural numbers. This is summation of squares of first 4 natural numbers, and this is 20. So we will get numerical answer very quickly here. Maybe little, because these numbers are less, we will get the answer. And it is good if we can really find out numerical answer by this way, 11 plus 19 plus something. And if we find out numerical answer this way, they both will match. That is what is going to happen. So these are the properties of sigma notation. Now we have learned them using numbers, but it is okay if you have understood, and they will work because the proofs are running in our mind. We have not done it for I goes from 1 to n, what will happen? We have not written in that fashion, but we have learned it with proofs. When we learn arithmetic progression, geometric progression, etc., sequence and series progressions, we will extensively use this sigma notation. And at that time, you are really going to require to work with that and find out the final answers. Right now, we have just understood how it works, what is the mechanism, and that is where we will stop. We will not solve problems using sigma notations at the moment. But because we want to write down that binomial theorem in sigma notation, we have learned it. Extensive use of sigma will be in progressions. Whenever we learn arithmetic and geometric progression, we will do that. Okay? And therefore, now it is time to write down binomial theorem. Binomial theorem. A plus B bracket raised to n is equal to sigma r goes from 0 to n choose r into a raised to n minus r into b raised to r. This is the statement. You must remember this statement and use it accordingly. If n is equal to 7, then we had written sigma notation. R goes from 0 to n choose r. Therefore, n choose 0, a raised n minus r. N is equal to 7. R is equal to 0, 7. B raised to r, b raised to 0. Plus, because of sigma, plus n choose 1, a raised to 6, b raised to 1, plus n choose 2, a raised to 5, b raised to 2, plus plus n choose array. Wherever n is there, I should write 7. Because it is 7. Right? Understood? This is important. So, therefore, immediate application of a binomial theorem one plus x raised to 5 Can you expand 1 plus x raised to 5? Easy. 5 choose 0, 5 choose 1, 5 choose 2, 5 choose 3, 5 choose 4. That is the answer. Now what should I ask you? Okay, let me ask you one important question. We know a plus b raised to n is sigma r is equal to 0 to n choose r, a raised to n minus r, b raised to r. Now what I want to do is, of binomial coefficient. N choose 0 plus n choose 1 plus n choose 2 plus dot 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 n choose n is equal to how much if n is equal to 7? Okay, the answer for n is equal to 7 is 128, which is 2 raised to 7. But if this summation of binomial coefficients, all binomial coefficients added when n is equal to n, it is going to be 2 raised to n. Is it correct? Let us check. When n was 5, we have those coefficients with us. 1 plus 5 plus 10 plus 10 plus 5 plus 1. Array 32. Correct? It is 2 raised to 5. Why? No, you are supposed to write something and show it. A is equal to 1 and B is equal to. A is equal to 1 and B is equal to 1. All these terms which are sitting here, they will become 1. They will not contribute to anything to the summation in RHS, and only summation will be of binomial coefficients, because n choose 0 followed by a raised to n minus r, b raised to r, a raised to n minus r, that is n, b raised to 0. Here a raised to n minus 1, b raised to 1. All those things, the coefficients will end up being 1, 1, 1, and we need not write those ones, and hence it will be a summation of coefficients. And in RHS, if we see, it is 2 raised to 5, because a is equal to 1, b is equal to 1, 1 plus 1, 2. So the principle that we are using to solve this problem is counting the same quantity in two different ways. Counting same quantity in two different ways. Which will give us the identity. And the identity is sigma r goes from 0 to n, n choose r is equal to 2 raised to n. 2 raised to n.
But what if we take a is equal to 1 and b is equal to 1, it will be in that 2 raised to n, just because a plus b is equal to 2.
Yes.
Then,
Yes.
but like, what if we take other number?
What if you take other numbers? Then you will get other result. We are looking for this result right now. Na? Therefore, choice of A and choice of B that we have made is 1, 1. Correct? And therefore, we have got this identity. Now,
But what if we take a as 2 and b as 3? Like, how will we prove it then?
no, I mean, at that time you will not be able to prove anything, because if A is equal to 2 and B is equal to 3, the LHS will be 5 raised to say 7 and RHS will be 7 choose 0, 2 raised to 7 plus 7 choose 1, 2 raised to 6, 3 raised to 1 and so on. We will not be able to prove any identity like because these guys are present there. But because if we take 1 and 1 both of them, these people disappear because 1 raised to something is 1 always. And hence we end up getting only summation of binomial coefficients. So it's a special case which we are using to get an identity. Okay. Now,
Sir, stop recording.
okay, now let it be. We wish to give one more proof for this identity. What is the identity that we are discussing? This identity. We wish to give one more proof for this, and I will explain you this proof first, and then maybe the next proofs you yourself should tell. That is called combinatorial proof for
Sir, can you repeat? Your voice broke.
combinatorial proof for the identity n choose 0 plus n choose 1 plus n choose 2 etc. I should do it right now, or you require to know some set theory for that. Okay, I will postpone that. But remember this, right now we have proved using a is equal to 1 and 1. Now, can we do it? Find out what is n choose 0 plus n choose 2 plus n choose 4, and maybe if I replace n, let us do numerically first.
Sir, we can do the proof like this, that if we have n-digited number, then how many numbers can we make with that number without repetition?
We will do something like that, but then we require a little bit of set theory for that, and I will do it once I explain you what sets are. And simultaneously, I will ask you another question. Okay, give me these two answers. Okay, the answer for first is 512. Answer for second is also 500. It is equal to 2 raised to 9. This is equal to 2 raised to 9. So, therefore, for n if we wish to write similar result, sigma r goes from 1 to, how do I write this in sigma notation? First one, let me write, r goes from 1 to, how many terms are there, or maybe r is equal to 0, 0 to 1, 2, 3, 4, 5, 6 terms are there, 6 terms. 10 choose 2r. No. Sorry, 5.
Yes, sir, 10 choose 2.
10 choose 2r, but it is 5. 0 to 5, 10 choose 2r is equal to 2 raised to 9. And the second,
Sir, it should be 6 only, not 5, I think.
there are 6 terms and I am starting from 0, therefore 5.
Yes, yes.
R goes from 1 to 5. There are 5 terms here. 10, choose R is equal to 1, 2R minus 1. Correct? R is equal to 2, 3. R is equal to 3, 5. R is equal to 4, 7. R is equal to 5, 9. Is also equal to 2 raised to. Therefore, maybe we should find out n choose 0 minus n choose 1 plus n choose 2 minus n choose 3 plus dot 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 plus or minus, we don't know, last term. Like this we should go, and the last term will be n choose n. Now if n is odd, then the last term will be negatively signed, minus 1 raised to minus 1 raised to n. Okay, that will be our last term. If n is even, last term will be positive. If n is odd, last term will be negative. So can we find out how much is this? For example, for numerical, 15 choose 0 minus 15 choose 1 plus 15 choose 2 minus 15 choose 3. Suppose I want to do it like this, and 15 is an odd number, therefore 15 is an odd number. Is this correct? If n is even, then the last term is positive. If n is odd, then the last term will be negative. So if n is 15, last term will be minus 15 choose 15 is equal to how much? Can we find out? Can you write the expansion of? Can you write the expansion of 1 minus x raised to 10 equal? Write down expansion of 1 minus x is raised to 10. Let us see how you write it of this. You have to remember the binomial theorem. First term a is equal to, what is our binomial theorem? Sigma r goes from 0 to 10. A 10 choose r, a raised to 10 minus r, b raised to r. So r is equal to 0. First term 10 choose 0, a raised to 10, b raised to 0. Now in our case, b is minus x. You can write this summation as 1 plus minus x times raised to 10. Okay, so a is 1, so you can write 1 raised to 10 and minus x raised to 0 plus 10 choose 1, 1 raised to 9 minus x raised to 1 plus 10 choose 2, 1 raised to 8 minus x raised to 2 plus 10 choose 3, 1 raised to 7 minus x raised to 3 plus dot 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 plus 10 choose 9 my 1 raised to 1 minus x raised to 9 plus 10 choose 10 1 raised to 0 minus x raised to 10. Okay, now one more step. 10 choose 0 minus 10 choose 1 x plus 10 choose 2 x square minus 10 choose 3 x cube plus 10 choose 4 x4 plus dot 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 plus 10 choose 9 x raised, sorry, minus 10 choose 9, x raised to 9, plus 10 choose 10, x raised to 9. So if this expansion is true, and now if we substitute x is equal to 1 in this, put x is equal to 1. So 1 minus x, which is 1 minus 1, which is equal to 0 raised to 10, which is equal to 10 choose 0, minus 10 choose 1, plus 10 choose 2, minus 10 choose 3, plus 10 choose 4, minus 10 choose 5, plus dot dot dot, minus 10 choose 9, plus 10 choose. So alternate summation adds up to 0. This result we already know. If all of them are positive, it is 2 raised to n. अरे समझते का?
Sir, but how will the even summation be 0? I didn't understand that.
Even summation is not 0. All of them add up to 0. Plus minus becomes 0. Okay. And therefore, let me write down next step. This implies 10 choose 0 plus 10 choose 2 plus 10 choose 4 plus 10 choose 6 plus 10 choose 8 plus 10 choose 10 is equal to 10 choose 1 plus 10 choose 3 plus 10 choose 5 plus 10 choose 7 plus 10 choose. We have proved this. Both of them are equal. All even ones add up to equal to odd ones. And therefore, when we have the entire summation, let me complete the proof. When we have sigma r goes from 0 to n, 0 to 10, 10 choose r, that is complete summation, which we said equal to 2 raised to n, is actually equal to 2 times either sigma r goes from 0 to 5, 10 choose 2r, or it is equal to 2 sigma r goes from 1 to 5, 10 choose 2r minus 1. बघा हे समजतंय का? These two guys are equal, so 2 times these two guys is going to be total summation of all binomial coefficients, or 2 times these two people is going to be total summation of all binomial coefficients. And therefore, sigma r goes from 0 to 5, 10 choose 2r. That means even ones add up to 2 raised to n upon 2, which is 2 raised to n minus 1, which is also equal to sigma r goes from 1 to 5, 10 choose 2r minus 1. That is what we wanted to prove. We did it for 10, but it will work for n. 1, 3, 3, 1. If n is equal to 3, we get binomial coefficients like this. So 1 minus 3 plus 3 minus 1 add up to 0. If n is equal to 4, our binomial coefficients are 1, 4, 6, 4, 1. If first one positive, second negative, third positive, fourth negative, fifth positive, oh, still they add up to. Here they are same, therefore equal and 0. But here they are not same, still they add up to 0. And therefore summation of this plus this plus this is equal to summation of this plus this. If n is equal to 5, again they will be 1 minus 5 plus 10 minus 10 plus 5 minus 1. Add up to 0. If n is equal to 6, they will be 1 minus 6 plus 15 minus 20 plus 15 minus 6 plus 1. Oh, let us see. 32 plus and 32 minus 0. Therefore, this plus this plus this plus this is 32, 2 raised to 5, power is 6, n is 6, answer 2 raised to 5, this plus this plus this 2 raised to 5, n is 6. So all odd ones add up to 2 raised to 5, all even ones add up to 2 raised to 5. I wait, you write down whatever you have understood in your 2x plus 1 upon 2x plus 1 upon 5x bracket raised to bracket raised to 8 is equal to, it will be some expansion, correct? Find x free term in this expansion. Okay, what is the question? 2x plus 1 upon 5x bracket raised to 8. We can write the binomial expansion of this, all 9 terms. Now if this index is 8, there will be 9 terms. Why? Because our r starts from 0. What will be the term which will not have x? Many terms will have x. Rather, majority of the terms will have x. Only one term will be there which will not have x in it. What is that term? Numerical value of that term. When do you think? Now, what is our general term? 8 choose r, 2x raised to 8 minus r, 1 upon 5x raised to r. Correct? So, x raised to 8 minus r and x raised to minus r. I mean, I hope you are okay with this kind of indices. If we take powers of x in the expansion of this, x raised to 8 minus r upon x raised to r. And now we want these two guys to get cancelled. Therefore, this is x raised to 8 minus r, which we want x raised to 0. We want it to be 0. Therefore, r is equal to 4. The moment we get r is equal to 4, which you must have done it orally also, we get the coefficient as, I mean the fourth r is equal to 4 wala term. 8 choose 4, 2x raised to 4 and 1 upon 5x raised to 4, which eventually becomes 8 choose 4 is 70, right? 70 into 2 raised to 4 upon 5 raised to 4. 1 5 is gone along with this and you get 14 into 16 upon 125, which is 224 and 20. This is the middle term and you will have free from x. Last 7 minutes, one more numerical and we are done. 3x raised to 2 plus 1 upon 2x raised to 3, wait, bracket raised to say 7 Bracket raised to 7. Will we have a term free from? Yes, I think so. Find x free term.
Sir, it is 2x raised to 3 or 2x?
It is only 2x. Here. And here it is 3x square. I am not sure whether it will be. Let me check. But I think the problem will be correct. Check. It's a bad number. Let me make it equal to 8 only, or 10 here. Power 10, huh? Okay, otherwise it is not happening. Change this power to 10. Okay. Still it is not happening.
Sir, I think no.
Sir,
Okay.
R
Sir,
is
for,
coming in
for
There
our
also
side
fraction.
it
does
is
not
not
happen.
happening.
Sir,
So
R
I
is
think
it is
20
R is
by
in
3.
fraction.
so we should take 9.
Sir, 10 in place of 10, there should be a multiple of.
Now it will happen. Do it. Still it is not. Still it is not.
But instead of
So we can take
Sir,
2x
we can
square.
make it. Yes, sir.
we
12.
can, yes.
Yes, we can do this one.
नहीं होता है, होत नहीं है.
Sir, it is not happening at all.
Let
We
us.
can,
Sir,
sir, we
we
can
can
take
take
12.
the
Sir, we can take 6, I think.
अरे
Sir, any multiple of 3?
yes, sir.
So if
Sir,
we take
12.
9, it will happen.
Sir, any multiple of 3 will do.
Yes.
No, sir, I think it would happen.
अरे तुम्ही नसतात ना तर माझं पोट कसं भरलं असतं एवढे सजेशन मला देतात. Okay, let me finish this. It is first balance of the index of x raised to, so it is 12 minus r times 2, because this is 2, minus 4r is equal to 0. That makes it 24 minus 6r is equal to 0, implies r is equal to 4. And therefore, using binomial theorem, it is 12 choose 4, 3 raised to 4 into 1 upon 2 raised to 4. 12 choose 4 is 495. Into
3 raised to?
So 3 raised to 8, right?
3 raised to? Yes, sir.
No, this is x square only. It is not 3 raised to 2. Okay.
No, sir, but it
Yes,
should
sir.
be n.
3 raised to 8. Yes.
Yes, sir. So n minus 1.
Yes. 8 here. And then this answer is not correct.
Sir, it is 495 into 3 power 8 by 16.
Yes, sir.
495
Yes, sir.
into 3 raised to power 8 by 2 raised to power 4.
Sir, 3 power 8 is 6561.
Is it? But it is too big number. I mean, it's okay. We will solve few more problems on binomial tomorrow and then move on.